Hello. If you're building your own solar systems, one of the problems you have is powering the electronics. You can do this with dropping resistors or voltage regulators, but if any of those fail, it can put a lot of voltage into your electronics, and you'll have some major failures. I like using these little power supplies that you can get on eBay. They're 220 volt to 110 volt, and they produce 12 volts at 1.2 amp at the rated input voltage. But I've found that these can easily operate down at very low voltages, as low as 32 volts. I have a 36 volt system, and that's around 52 volts at power point. So these make a good match, and you can get a couple hundred mA out of them, because you're operating at a reduced input voltage. But they'll power most things. Now internally, they're much like any kind of wall wart. They have a single IC. They make a variety of them, and they all have a little, if you look, a little high value resistor, anywhere from 470,000 ohms to 2.2 meg. This one uses 2.2 meg. This resistor is up here, and it powers pin 1 of this IC. It could vary for ICs, but that provides the initial start current to get the oscillator running, and then once it powers up, it'll self-power itself, so it's not needed after that. These chips tend to have internal resistance of the FET somewhere around 30 ohms, so you want to feed as much voltage to them as possible. So on this one, I eliminate the diodes. Basically, I short out the input diode, so the line input goes right to the capacitor, and I short out this diode, so the neutral goes right to the negative of the capacitor. And that still provides this diode here, so if you try to put reverse voltage on it, it'll blow the fuse. And once you're finished, basically it looks like this. You got the fuse, a diode in parallel with the capacitor, and that's it. You haven't lost that 1.2 volts. Doesn't sound like much, but these chips actually heat up, and if possible, get a little heat sink for them. Bend a little bit of aluminum and epoxy it on, because the chips will get hot if you try and pull upwards of around 300, 400 milliamps out of these. The basic circuit looks like this. You have your half-wave rectifier, input capacitor, the green LED on the board, and there's a little filtering inductor, and then your standard TL431 circuit. As the voltage increases, this TL431 turns on, and the LED of the opto isolator lights up, and it turns off the oscillator of the switching power supply. Now if you're running an Arduino or other small microprocessors like that, you may just want 9 volts instead of the 12 volts. So they have a little 20K resistor. It's hard to get on top of the board, but underneath there's plenty of room to put it. And you can put a 47K in there, and that'll make it 9 volts, which is ideal for most of the small microprocessor supplies. Now this chip is a SW2604, but whatever you buy, it's be flavor of the week. Whatever came cheapest. This same trick works for the TNY processors and almost anything. There's always a high value resistor, and you want to bridge that. So here's my little mod. As you can see, I just did a solder bridge for the diode over here, and then I have this red wire jumper across the other diode. Down here you can see the resistor I bridged across the 2.2 megohm resistor, and over up here is where the 20K resistor is that you can bridge a 47K across if you want 9 volts. But these supplies are very useful. I use them for high side drivers. NFETs are very cheap. And so I put them up high, and I drive them with an opto-isolator, but it has to have an isolated supply. And, you know, these are only $1.25 each shipped. So it's fine to have a couple of them. And the nice thing about these is that if it should fail, it'll fail putting out no voltage. Whereas if you have a shorted regulator or an open Zener, you'll be putting a lot of voltage into your electronics. So that's my tip for the day. Thanks for listening.